Welcome in. In this episode, we are going to follow wind, the quiet air at the edge of a curtain, the cool breath of a breeze on warm skin, the invisible pressure that moves grass and clouds, and the stronger forces that can damage roofs, carry debris, push fire, and remind us that air is not empty at all. Now let the room grow a little softer. Turn down those lights, pull a blanket close, and let the first small movement of air carry us in. We will begin gently, because wind usually arrives gently. It slips through a screen. It lifts a loose edge of fabric. It passes across the face before the mind has chosen a name for it. You may notice it only because something else has moved. A leaf, a strand of hair, a flame, a thin shadow on the wall. Then, slowly, we will let the same subject widen. The breeze that cools the skin belongs to the same world as the wind that bends trees and carries rain sideways. The air that fills the lungs belongs to the same world as the atmosphere studied by weather offices, fire crews, engineers, and old philosophers who wondered whether air might be more than emptiness. This will not be a storm warning lesson, and it will not be a dramatic disaster story. It will be a calm look at wind as ordinary comfort, physical force, and ancient idea. We will keep the dates where they belong, keep the sources close, and let the facts move slowly enough that they can become restful. So breathe once, without effort. Let the breath leave. Let the next breath arrive by itself. The first wind in a life is not usually named as wind. It is simply air moving across skin. A baby feels it before understanding it. A person lying near an open window feels it without measuring it. A tired room changes when air begins to move through it. The room is still the same room, but it no longer feels sealed. On a warm day, a breeze can feel like relief because moving air helps carry heat away from the skin. If sweat is present, moving air can also help evaporation, and evaporation is one of the ways the body cools itself. The National Weather Service explains in its heat index guidance that sweating does not cool the body unless the moisture evaporates. Evaporation is the cooling process. That simple fact is one reason a breeze can feel so kind. The air moves, moisture leaves the skin more readily, heat goes with it. The body is not thinking about thermodynamics. It only knows that the afternoon has become more bearable. CDC and NIOH guidance on heat stress makes the same general point in practical language. Cool, dry air moving over exposed skin can remove heat from the body. Clothing, especially clothing that traps heat or blocks evaporation, can interfere with that exchange. In ordinary life, the lesson feels familiar. A loose shirt in a breeze feels different from a heavy coat in still air. Wind is not always cooling in a helpful way. A very hot, dry wind can be hazardous, and official heat guidance treats heat, humidity, wind, sunlight, clothing, and activity as parts of a larger picture. So we should not say that wind is always good for the body. It is more careful to say that a breeze can feel good under the right conditions because moving air can help carry heat and moisture away. In cold weather, the same movement of air changes character. The National Weather Service describes wind chill as a measure of heat loss from exposed skin caused by wind and cold. When wind increases, it draws heat from the body more quickly, lowering skin temperature, and if exposure continues, affecting internal body temperature as well. The ordinary body knows this before the chart does. On a still cold night, a coat may feel sufficient. On a windy cold night, the same coat may suddenly seem thin at the cuffs, neck, and face. The air is not colder in the thermometer sense, but it is more effective at taking heat away. The National Weather Service also explains that wind chill is defined only for temperatures at or below 50 degrees Fahrenheit and wind speeds above 3 miles per hour. That boundary matters. It reminds us that words like feels like belong to a specific measurement context, not to every kind of weather, and not to inanimate objects in the same way. So the first feeling of wind is already double. A warm breeze can be pleasant because it helps remove heat. A cold wind can be uncomfortable or dangerous because it removes heat too quickly. The difference is not that the air has become a different kind of thing. The difference is context, temperature, moisture, skin, clothing, exposure. For a sleep video, this is a good beginning. Wind begins at the scale of the cheek and the hand. Before hurricanes, before tornadoes, before ancient cosmology, wind is the small movement that tells the body the world is open. Wind is difficult to picture because air is usually invisible. We see its effects instead. A curtain moves, dust rises, smoke leans to one side, tall grass bends in waves, clouds travel above a field, a candle flame narrows, brightens, or goes out. The wind itself remains almost transparent. That invisibility has always made air philosophically tempting. Something unseen is clearly acting. It surrounds the body. It enters the lungs. It leaves the mouth warmed or cooled. It can be gentle enough to miss, then strong enough to reshape a landscape of loose things. Modern language can say that wind is air in motion. That sentence is plain, but it contains a great deal. Air has mass. Moving air carries momentum. Moving air can press on surfaces. If it moves fast enough, it can move other things. Leaves first, then dust, then branches, then water, then roof edges, signs, vehicles, and fragments of buildings. The important point is not to make the wind mysterious in a false way. It is not magic. It is not an invisible intention. It is matter moving through space, shaped by pressure differences, temperature contrasts, the turning earth, terrain, storms, and local surfaces. But because it is invisible most of the time, it has always felt like more than a simple object. Imagine standing in a dark field at night. The sky is almost still, but the grass is not. You cannot see the air crossing the ground. You can only see each blade answer it. The moving shape passes through the grass like a thought passing through a mind, present, real, and difficult to hold. That is one reason ancient thinkers could make air into an idea. Water is visible, earth is visible, fire is visible. Air is often known by evidence. It is the missing body that proves itself by moving other bodies. In this episode, we will keep that double sense. Air is physical. Air is also suggestive. It is measurable, but it is also the ancient image of breath. It fills sails, moves clouds, cools skin, feeds flame, carries dust, and becomes a natural metaphor for life because living things breathe. The story of wind is therefore not one story. It is a set of doors. One door opens onto weather. One opens onto the body. One opens onto fire. One opens onto storm damage. One opens onto philosophy. All of them turn on the same quiet fact: the invisible can be real. Before we move into storm scales, we can ask the plain question: why does wind begin at all? The National Weather Service glossary defines wind as the horizontal motion of air past a given point. That is wonderfully simple. The same glossary explains that winds begin with differences in air pressure. Pressure that is higher in one place than another sets up a force pushing from high toward low pressure. The greater the pressure difference, and the shorter the distance over which that difference occurs, the stronger the force can be. Meteorologists call that force the pressure gradient force. NOAA jet stream gives the same idea through the phrase pressure gradient, the difference in pressure between high and low pressure areas. It explains that wind speed is directly proportional to the pressure gradient. As the pressure gradient increases, wind speed also increases at that location. This is a lovely thing to slow down. Pressure is invisible too. You do not see pressure on a weather map unless someone has drawn it for you. But the air feels it. Air is crowded more in one place and less in another. The atmosphere begins to adjust. On a weather map, the old letters H and L become almost symbolic. H for high pressure, L for low pressure. Lines of equal pressure, called isobars, can be drawn around them. Where those lines are spread far apart, pressure changes more gently across distance. Where those lines crowd together, the pressure changes more quickly, and the wind can become stronger. We do not need to teach a full meteorology course, but this one idea helps everything that follows. Wind is not a random mood in the sky. It is the atmosphere responding to differences. There is a caution here too. We should not imply that wind always moves in a perfectly straight line from high pressure to low pressure. Earth's rotation, surface friction, terrain, storms, and local heating complicate the path. Noah's jet stream materials discuss the pressure gradient force along with the Coriolis force and other effects. For a sleepy telling, we can say it simply: pressure differences help begin the motion, and the turning earth and the shape of the surface help shape where that motion goes. Imagine a valley at evening. During the day, sun warms slopes unevenly. Air rises in some places and sinks in others. The wind along the valley changes direction with time. Now imagine a broad continent under winter pressure systems. Air moves around highs and lows on a scale too large to feel as a single shape from the ground. Then imagine a sea breeze, where land and water heat differently. In each case, the details differ, but the atmosphere is still answering in balance. This makes wind a wonderful subject for sleep because it can be approached at any scale: a breath at the lips, a window draft, a hillside breeze, a map of pressure, a storm system. The same idea grows without losing its quiet center. Air also has weight. We live at the bottom of the atmosphere, under a great depth of gas. Most of the time, that weight is steady enough that we do not think about it. But pressure changes, even small changes, can be measured. Weather instruments notice what the body may miss. Barometers once made pressure visible in columns of liquid. Modern sensors record it continuously. There is something peaceful in that. A room may feel still, but the atmosphere is never truly static. Pressure changes, air responds, clouds form, winds turn. The body breathes within a system far larger than itself. Now, the ordinary examples make more sense. The breeze through the screen is local motion. The gust under a storm cloud is stronger motion. The wind along a coast may come from the daily difference between land and water heating. The powerful winds around a storm belong to a much larger pressure pattern. The listener does not need to hold all of this sharply. It is enough to let the idea pass through. Wind begins where air is moved by difference: high and low, warm and cool, rising and sinking, crowded and less crowded. The atmosphere seeks adjustment, and the adjustment becomes wind. Before the strongest examples, it helps to stay with ordinary ones. Moving air first makes itself known by changing small things. Dust along a road lifts into a pale sheet. A door inside a house moves on its hinges when another door opens. A tablecloth flutters. A lake darkens in patches where gusts roughen the surface. The difference between a breeze and destructive wind is not a difference between two separate worlds. It is a difference of speed, exposure, surface, duration, and what the wind finds loose enough to move. A leaf offers little resistance. A branch offers more. A roof edge offers more still. But if wind gets under it, pressure and leverage can begin to matter. This is where wind begins to feel less like a sensation and more like a force. It does not only touch, it presses. It does not only pass, it transfers energy. It can push against one side of a building, while lower pressure, openings, uplift, or debris damage complicate what the structure experiences. For our purposes, we do not need to turn the story into an engineering lecture. The calm truth is enough. Moving air can exert force. Faster moving air can exert more force. Different shapes respond differently. A flat surface, a roof edge, a sign, a trailer side, or a tree canopy can give wind something to push. Storm scales help organize this force, but they must not be mixed together carelessly. Hurricane categories use maximum sustained winds. Tornado ratings in the enhanced Fujita scale use estimated 3-second gusts, inferred from surveyed damage. Ordinary weather station winds are measured another way. These distinctions matter because otherwise the story would make numbers sound more comparable than they are. Here, one distinction matters. Separate sustained hurricane winds from tornado estimates and from ordinary gusts. The number alone is not the whole story. The measurement method, duration, exposure, and damage context all matter. Still, numbers can be helpful when used carefully. They let the listener feel the step from ordinary wind to damaging wind. They also keep the story honest. A calm voice can still use exact numbers. In fact, exact numbers often make the story calmer, because they replace vague drama with clear boundaries. Wind at the scale of a breeze helps the body rest. Wind at the scale of a storm presses on matter. Between those two lies a long continuum. Rustling grass, bending branches, rattling windows, lifted dust, rolling waves, broken limbs, damaged roofs, and then, in violent cases, structures and vehicles moved in ways that seem startling, because we forget that air has weight and motion. The old philosophers did not have the National Weather Service, the National Hurricane Center, or Doppler radar, but they had the same sensory puzzle. Air surrounds us. Air moves. Air changes things. How can something so difficult to see be so necessary? Before the hurricane scale appears, we can pause with the idea of measurement itself. Wind has always been felt before it was measured. A person knows a breeze by skin, a gust by balance, a storm by sound at the window. But feeling alone is not enough when people need to compare one wind with another. Measurement gives moving air a shared language. Miles per hour, knots, sustained wind, gust, category, rating, warning, watch. These terms can sound technical, but they exist because wind changes consequences. A breeze lifts a curtain. A stronger wind breaks branches. A still stronger wind damages roofs, brings down power lines, and makes travel dangerous. We can let those terms arrive slowly, like labels placed on a table. Sustained wind is not the same as a brief gust. A hurricane category is not the same as a tornado rating. A direct measurement is not the same as an estimate inferred from damage. These differences are not fussy details. They are the guardrails that keep the episode honest. This is especially important because wind is invisible. If a flood reaches a mark on a wall, the height can be seen afterward. If fire burns a line across a field, the edge is visible. Wind leaves evidence, but the wind itself has passed. Investigators and forecasters often work from instruments, damage, radar signatures, and reports. They reconstruct the invisible from traces. That reconstruction can be beautiful in a quiet way. A damaged roof becomes evidence. A snapped tree becomes evidence. A pressure map becomes evidence. Radar sees motion, and sometimes debris. A scale turns scattered observations into a common language. For the listener, this can become a restful pattern. First sensation, then measurement, then meaning. The body feels wind. Instruments measure wind. Philosophy asks what wind reveals about the unseen world. The National Weather Service glossary gives a plain definition. Wind is the horizontal motion of air past a given point. It also says wind speed is usually given in miles per hour or knots. That is a small sentence, but it marks a transition from experience to record. Once wind is measured, it can be compared across place and time. A storm today can be set beside a storm in the past. A forecast can be issued. A warning threshold can be defined. A scale can be revised, as the Saffir-Simpson thresholds were revised for certain categories effective May 15, 2012. This is why dates matter in our careful rule. Dates keep the story from floating. February 1st, 2007 is not just a number. It marks when the enhanced Fujita scale became operational. May 15, 2012 is not just a number. It marks when the adjusted Saffir-Simpson thresholds took effect. The episode can remain sleepy while still being exact. In fact, exactness can make it sleepier. There is less strain when the listener is not asked to accept vague claims. The voice can say what is known, what is estimated, what remains uncertain, and what is left unsaid. Now the first major scale can arrive. A hurricane is not only wind, and it is important to say that clearly. Hurricanes can also bring storm surge, rainfall flooding, and tornadoes. The Saffir-Simpson hurricane wind scale does not measure all of that. The National Hurricane Center describes it as a 1 to 5 rating based only on a hurricane's maximum sustained wind speed. That boundary is useful. It keeps the wind part of the story clean. The scale estimates potential property damage from wind, but it does not tell the whole danger of a storm. A lower category storm can still be deadly because of water. A higher category storm may contain several hazards at once, but when we are talking about wind itself, the Saffir-Simpson scale gives exact ranges. Category 1 begins at sustained winds of 74 miles per hour and runs through 95 miles per hour. Category 2 runs from 96 through 110 miles per hour. Category 3, the first major hurricane category, runs from 111 through 129 miles per hour. Category 4 runs from 130 through 156 miles per hour. Category 5 begins at 157 miles per hour or higher. Those numbers can be spoken slowly: 74 to 95, 96 to 110, 111 to 129, 130 to 156, 157 or higher. The categories are a staircase of sustained wind. The current Category 3, 4, and 5 mile per hour thresholds were adjusted for unit conversion consistency, effective May 15, 2012. That detail does not need to become the center of the story, but it is worth preserving. The threshold change came from the National Hurricane Center notice dated March 1, 2012, and took effect on May 15, 2012. The damage descriptions on the National Hurricane Center scale become more severe as the category rises. In Category 1, well-constructed frame homes can have roof, shingle, siding, and gutter damage. Large branches can snap, shallow-rooted trees may fall, and damage to power lines and poles can produce outages. By Category 2, winds are described as extremely dangerous and capable of extensive damage. Roof and siding damage can be major. Trees may be snapped or uprooted. Roads can be blocked. Power loss can last from several days to weeks. Category 3 is where the scale uses the word major. Well-built framed homes may incur major damage or removal of roof decking and gable ends. Trees may be snapped or uprooted, roads blocked, and electricity and water unavailable for days to weeks after the storm passes. In Category 4 and Category 5, the damage language becomes catastrophic. The scale describes severe damage to well-built framed homes in Category 4, including loss of most roof structure or some exterior walls. In Category 5, a high percentage of framed homes may be destroyed, with total roof failure and wall collapse. This is destructive language, but we can keep it calm. It does not need to shout. It should let the facts stand. The force of wind does not need theatrical help. A quiet list of what can happen to roofs, walls, trees, power poles, roads, and water systems is already enough. For the listener, this section can become almost architectural. Imagine wind meeting the built world: roof edges, siding, gutters, branches, poles, lines, roads. The air moves, and each object answers according to its shape, strength, anchoring, exposure, and luck. Then, let the picture soften again. After the wind, there is often a strange stillness. Branches lie across roads. The air that had been roaring is only air again. Tornadoes require a different kind of care. They are not rated the same way hurricanes are rated. The Enhanced Fujita Scale, or EF scale, became operational on February 1st, 2007. The National Weather Service uses it to assign a tornado rating based on estimated wind speeds and related damage. The word estimated matters. The EF scale is based on surveyed damage indicators and degrees of damage. Trained surveyors compare the damage to known categories: 1 or 2 family residences, mobile homes, schools, warehouses, towers, poles, hardwood trees, softwood trees, and other indicators. From the damage, they estimate the range of wind speeds the tornado likely produced. The EF scale uses 3-second gust estimates at the point of damage. These are not the same as standard surface observations from ordinary weather stations. That difference must remain clear here. A tornado rating is not usually a simple anemometer reading taken inside the tornado at ground level. It is a damage-based estimate. The ranges are exact enough to use. EF0 corresponds to estimated 3-second gusts from 65 to 85 miles per hour. EF1 is 86 to 110. EF2 is 111 to 135. EF3 is 136 to 165. EF4 is 166 to 200. EF5 is over 200 miles per hour. Again, the numbers can move slowly. They are not there to excite. They are there to clarify. They help us understand why tornadoes must be discussed with careful language. At the upper end, the wind estimates are beyond ordinary experience. Tornadoes can damage or destroy homes and buildings, but we can never pretend that every structure responds the same way. Damage depends on intensity, construction, anchoring, exposure, debris impacts, and the exact path. One building may be struck directly, another may be nearby but shielded or less exposed. One structure may be well anchored, another may fail sooner. The National Weather Service EF scale includes damage indicators for 1 and 2 family residences, mobile homes, apartments, motels, schools, warehouses, towers, poles, and trees. This lets us discuss houses, buildings, mobile homes, trees, and infrastructure without inventing examples. The category system itself shows what surveyors look at. The NOAA Storm Prediction Center's Tornado FAQ adds another layer. It explains that tornado damage usually happens in 2 direct ways: exposure to extreme wind and impact by flying debris. This is essential for the wind episode because it keeps the debris section grounded in official language. In a developed area, a tornado can fill the air with small and large projectiles: boards, broken glass, nails, shingles, gravel, wire, cables, sheet metal, hardware, tree parts, rocks, bricks, appliances, furniture, household items, vehicles, and parts of houses. We do not need all of those in every sentence, but the list helps the visual imagination understand the danger without exaggeration. For a sleepy telling, the tone has to remain respectful. We can say what tornadoes do. We do not need to dwell on fear. A calm voice can observe that the wind is no longer only pressing on a wall. It is also carrying pieces of the world through the air. Modern radar research also treats debris as a real signal. NOAA's National Severe Storms Laboratory notes that dual polarization radar can help detect debris from tornadoes, which can assist forecasters in confirming damaging tornadoes, including at night or when rain wraps the circulation. That fact belongs here because it changes debris from an odd anecdote into a studied part of severe weather. Debris is not only what remains afterward. In some cases, it is part of what radar can detect while the storm is happening. The tornado discussion can close by returning to scale. A window, a roof, a tree, a mobile home, a warehouse wall, a power pole, each becomes evidence in a damage survey. The wind passes, the survey begins, the invisible is reconstructed from what it changed. This part can be especially careful because it is easy for strange tornado stories to become folklore. A careful claim is that small material can sometimes embed in harder surfaces when momentum is high enough, especially at cracks, holes, mortar, hollows, or weakened places. The NOAA Storm Prediction Center Tornado FAQ explains this with the idea of momentum. A light or small object may seem too soft or too weak to damage something harder, but speed changes the encounter. A thrown object and a fired object are not the same experience for the target. The FAQ discusses odd damage examples including straw embedded in tires and boards penetrating walls, trees, and cars. It also explains that a solid object may penetrate a stationary, harder target, especially if it strikes cracks, holes, hollows, or weaknesses. It gives an example of wood or straw being driven into a crack or hole in a brick wall, or into softer mortar that is being compromised. So we can say this: in violent wind, debris can behave in ways that look almost impossible afterward. Straw, wood, boards, glass, gravel, metal, and building fragments can become projectiles. Small material can sometimes lodge in harder surfaces because speed gives it momentum, and weak points give it a place to enter. There is one concrete-related documented example, but it is different. In the National Weather Service Huntsville page on the Lawrence County, Alabama EF4 tornado of February 6, 2008, the report says fence posts embedded in concrete were ripped out of the ground and vaulted 50 to 100 feet in several directions. That is not the same as grass penetrating concrete. It is a sourced example of tornado force acting on objects anchored in concrete. This distinction matters. A vague version would sound dramatic. The precise version is better. It says what the record says, and no more. Imagine the aftermath slowly, without sensationalism. A board is in a place where a board should not be. A piece of metal is wrapped around something solid. Gravel has struck glass. Straw has lodged where straw seems too soft to lodge. Surveyors look carefully, because every piece of debris tells a small part of the wind's path. Momentum is a quiet idea. Mass and speed. Direction and impact. Wind gives speed to objects that had been still. Once moving, those objects carry energy into whatever they meet. In a calm room, a straw is nearly weightless. In a field after a tornado, straw may become evidence of speed. The difference is not the straw alone. It is the moving air that carried it. This part can remain almost meditative. The world is made of small things: nails, shingles, gravel, bark, glass, leaves, dust, splinters. Wind can gather small things into danger. Then, after the storm, the same small things lie still again. Semi-trailers, semi-trucks, a truck, and a boxcar-related example are source-supported. A better sentence is, documented National Weather Service reports show that violent tornadoes can overturn, badly damage, move, or throw heavy vehicles and equipment in specific cases. On January 17, 2012, a National Weather Service Louisville event page reported that an injury occurred as a tornado crossed I-265 when two semi-trailers were blown over. We can use that as a dated example of semi-trailers being overturned by tornado winds. It should avoid lingering on the injury. In the March 28 to 29, 2007 Texas Panhandle damage surveys, a National Weather Service Amarillo page reported 3 semi-trucks caught and badly damaged in a tornado on Interstate 40. The same survey described a refrigerated boxcar that had contained tools and horse feed. It was rolled northward 11 times and found on its side almost 100 yards north of its original location. Because the enhanced Fujita scale became operational on February 1, 2007, that March 28-29, 2007 survey belongs very near the beginning of the EF era. If we mention this in chronological order, February 1st comes first, then March 28-29. In the Lawrence County, Alabama EF4 tornado of February 6, 2008, National Weather Service Huntsville reported a truck thrown more than 100 yards into an open field. The same event page reported fence posts embedded in concrete, ripped out and vaulted 50 to 100 feet. These are strong examples, but they should be used sparingly. The purpose of the wind episode is not to make the listener tense. It is to show that air in motion can act on matter at many scales: skin, curtains, trees, roofs, trailers, trucks, boxcars, and fire. We can slow down and make the point this way. A parked trailer has broad sides. A truck has surfaces the wind can strike. A boxcar is heavy, but it also has shape. Under violent conditions, wind and debris do not need to behave like ordinary weather. They become a moving field of force. Then, gently, we can step back. The same planet contains the breeze that cools a porch and the tornado that moves a truck. That contrast is not a contradiction. It is the range of moving air. For the listener, this part can end with quiet honesty. Some wind is pleasant. Some wind is dangerous. Both are real. Both belong to the invisible world around us. Wind and fire belong naturally together in the elemental series. The fire episode already touched the idea that air matters to flame. Here in the wind episode, the relationship becomes broader. Wind can help fire spread by changing where heat, flame, and embers go next. The National Wildfire Coordinating Group describes wind and fuel moisture as the two most important weather-related elements affecting wildland fire behavior. Wind is variable and difficult to predict near the surface because terrain and local heating and cooling affect it strongly. NWCG explains several ways wind affects fire. It can carry away moisture-laden air and hasten the drying of fuels. Once a fire has started, wind can aid combustion by increasing oxygen supply. It can carry heat and burning embers to new fuels. It can bend flames closer to unburned fuels ahead of the fire. The National Weather Service wildfire infographics say the same thing in simpler public language. Wind speed has a large effect on fire intensity and how fast fires travel. Wind pushes flame forward and closer to unburned fuel. Wind and thermals can carry sparks and firebrands downwind, increasing spread rates. This gives us the approved script wording. Wind can push flames forward. It can carry sparks or firebrands downwind. It can help a fire find new fuel. It can make a fire feel as if it keeps reaching ahead of itself. But the blocked claims matter too. Wind does not create fire by itself. Fire still requires ignition, fuel, and oxygen. Wind is also not the only factor in fire spread. Fuel moisture, fuel type, temperature, humidity, precipitation, and topography all matter. We can keep this beautiful and careful. Imagine a small flame in still air. It rises straight. Now imagine the same flame in moving air. It leans. Its heat reaches sideways. Sparks travel. Dry grass ahead of it warms. The shape of the fire changes because the air around it is moving. In a wildfire, this can become deeply serious. Wind bends flame toward unburned fuel. Wind carries embers. Wind dries fine fuels. Wind makes direction matter. A fire is no longer only where flame is visible. It may be preparing new fire downwind. The language can remain calm. No roaring soundtrack in the words, no cinematic panic, just the old connection. Air feeds fire, moves fire, and sometimes spreads fire beyond the place where it began. Philosophically, this is a powerful bridge. Fire looks visible and dramatic. Wind is often invisible, but the visible fire may depend on the invisible air. The flame shows us the wind by leaning. A candle under a draft, a campfire bending, a wildfire sending embers downwind. Each scene reveals air by the behavior of flame. Wind makes the invisible visible through fire. After the destructive section, we can deliberately return to restorative wind. Both sides matter, the dangerous and the good. The episode cannot leave the listener inside a storm. Good wind is not complicated. It is the breeze on a hot day. It is air moving through a room that had become stuffy. It is laundry shifting on a line. It is tall grass moving in long waves. It is the quiet pressure that fills a sail and lets a boat cross water without an engine. For body comfort, we can return to the approved cooling language. A breeze can feel good on a hot day because moving air helps carry heat away from skin and can help sweat evaporate. Sweating cools the body when sweat evaporates, and evaporation is a cooling process. We cannot overstate this. Not all wind is good, and not all heat is relieved by wind. But in ordinary warm conditions, the relief of moving air is one of the most familiar forms of comfort. Ventilation is another kind of good wind. Air exchange changes a room. It carries away odors, humidity, smoke, and staleness. We do not need to turn this into a technical ventilation lesson. The ordinary experience is enough. A window opens, a door opens, a room exhales. Sailing and movement can be included as human uses of wind without needing to make a specialized claim. A sail is a visible lesson in moving air. It shows pressure and direction. It turns invisible motion into travel. Good wind also has a psychological quality. People speak of clearing the air, getting fresh air, catching their breath. Not all of that language is scientific. Some of it is metaphor, but the metaphor grows from bodily truth. Air is needed. Moving air changes how a place feels. In the older philosophical world, this connection between air and life mattered deeply. Breath is the sign of life. A body breathes, then one day does not. Wind crosses the world, breath crosses the body. The boundary between weather and life becomes emotionally powerful. We can now drift toward the ancient section. We have felt wind as comfort. We have seen it as force. We have watched it move fire and debris. Now we can ask why an early Greek thinker might look at air and see not emptiness, but origin. There is a quiet middle ground between science and philosophy, where wind becomes a lesson in boundaries. Wind is most noticeable at edges. It finds the edge of a sleeve, the edge of a roof, the edge of a blade of grass, the edge of a wave, the edge of a flame. Without an edge, moving air can be hard to notice. With an edge, it becomes visible. Think of a shoreline. Wind crosses open water, and the water answers with ripples. At first, the ripples are small, almost like a texture. Then, if the wind continues, the surface gathers lines. The lines gather into waves. The waves lean toward shore. The air has not become water, but it has given the water shape. Think of a desert road. The air moves across loose dust. The dust rises, slides, and drifts. A shape appears where no solid object was moving a moment before. The wind has borrowed the dust as a body. Think of a winter field. Snow lies loose over harder ground. A low wind lifts the top layer, carrying it in pale ribbons close to the surface. The field seems to be breathing. Nothing large has changed, but the visible skin of the place is moving. Think of a room at night. The window is open only a little. A curtain lifts, pauses, and settles. The movement is so small that it feels almost private. The air outside and the air inside are touching through a narrow opening. The curtain becomes the line where one space meets another. Wind likes thresholds. Doorways, windows, valleys, coastlines, ridges, streets between buildings, gaps in fences, the open side of a porch. Air is continuous, but our world is full of boundaries, and boundaries make motion apparent. This is useful for the visuals. The wind episode cannot try to show air directly. It should show thresholds answering air. A curtain moving against moonlight, grass bending in shallow waves, reeds trembling at a riverbank, high clouds sliding slowly across stars, dust near the ground, soft enough to feel calm rather than harsh, a flame leaning without becoming frantic. The same principle helps the writing. Wind is known by what it touches. A person does not need to be told, wind exists, if the story lets the listener see the leaf move, hear the window seam, feel the coolness on skin, and watch flame bend. At the philosophical level, this becomes a larger thought. Perhaps some realities are known mostly through effects. You know breath by the rise of the chest. You know pressure by the motion it begins. You know attention by what it rests on. You know time by change. You know wind by the world responding. This does not need to become too abstract. The voice can stay close to the senses, but a sleep video can allow one or two thoughts to open and then settle. Wind is a good teacher of the unseen because it never asks to be seen directly. It is content to reveal itself through contact. There is another reason the episode can dwell here. After talking about hurricane categories, tornado damage, debris, vehicles, and fire, the listener needs a long, gentle bridge before ancient philosophy. The mind does not need to be left among broken roofs and projectiles. It should be brought back through grass, curtains, shorelines, dust, and breath. So we can breathe here. It can let the hard facts dissolve into quiet images without losing what those facts taught. Air can be pressure. Air can be danger. Air can be comfort. Air can be breath. Air can be the unseen medium of voice and thought. Only then should Anaximenes enter, not as an abrupt name from a textbook, but as a person in a very old world noticing what we have been noticing all along. That air is hard to see, impossible to live without, and powerful enough to make the visible world move. Before we enter the ancient sources, it is worth resting for a moment with the sound of wind. Wind itself has no voice in empty space. What we hear is air meeting things. Leaves, wires, grass, eaves, reeds, shutters, waves, the edge of a door. The sound is a relationship. That is why wind can sound different in every place. In a pine forest, it becomes a high, combed whisper through needles. In tall grass, it becomes a dry, brushing sound. At a window, it may become a low pressure at the seam, a soft thread of tone. Around a building, it may rise and fall as the air finds corners and openings. For sleep, gentle wind is useful because it has variation without demanding attention. It is not a melody with a hook. It is not a voice asking to be answered. It shifts, but it does not insist. The mind can follow it for a moment and then release it. Because this is a sleep episode, the subject includes destructive force. But the finished episode does not need to feel destructive. The strongest facts are framed in the middle, carefully and briefly, and then the episode returns to breath, night air, moving grass, and soft pressure. The listener can feel informed, not alarmed. Wind also teaches the eye how to rest. A still image of air is impossible, but a moving image of air is easy, if something else is allowed to move slowly. A curtain, grass, mist, a cloud, dust in late sunlight, reflections on water. Air can appear by moving the world gently. The same is true in language. The word wind can be too broad, so the story lets the listener feel the details. A breeze is not a gale. A gust is not a sustained wind. A hurricane category is not a tornado rating. A draft in a room is not a wildfire wind. Precise language makes the softness safer. There is also a kind of moral calm in admitting limits. We do not know every old detail about Anaximenes. We do not turn Stoic pneuma into modern science. We do not make every tornado anecdote into a universal rule. We do not say grass enters concrete when the source only supports a narrower debris momentum claim. We keep the air clear. The quietest wind in the episode is breath. Breath is ordinary, but it is never merely decorative. It is the most immediate way air becomes life. A person can ignore distant clouds and still know breath. In that sense, the wind episode becomes intimate before it becomes cosmic. The ancient Greek word pneuma can mean breath, wind, or spirit depending on context, but we can handle that carefully. It does not need to flatten every meaning into one modern idea. It is enough to let the family resemblance be felt. Moving air, living breath, unseen activity, the body animated from within. In a dark room, breath may be the only wind. It enters, leaves, enters again. The movement is small, but it belongs to the same atmosphere as clouds and weather. The body does not own the air. It borrows it for a moment, warms it, moistens it, returns it. That thought can lead gently into Anaximenes. If breath feels like life, and wind feels like invisible motion, and air surrounds everything, then air is not a strange candidate for an early principle. It is not the answer modern science would give, but it is an answer that grows from experience. It also helps the episode avoid a false split between the factual and the reflective. The factual parts tell us how wind moves, how it is estimated, how it is classified, and how it can affect bodies, buildings, debris, and flame. The reflective parts ask why something unseen became so meaningful. Breath is where those two parts meet. It is physical, measurable in principle, and yet personally felt. Experience can introduce the subject, but sources must carry the factual load. So the ancient section can feel earned. It does not arrive like a lecture inserted into a storm video. It can feel like the natural next step after a long observation of moving air. The body breathes, the room stirs, the grass bends, the flame leans, the storm leaves traces. The old thinker asks, what is this unseen thing that seems to be everywhere? So now, after storm scales and fire behavior and moving matter, we can become older and quieter. It can leave the weather office and walk toward Miletus, toward a shoreline, toward an early question asked under a bright sky. What is the world made from, beneath all its changes? Anaximenes of Miletus belongs to the early Greek philosophical world, often called pre-Socratic. The Internet Encyclopedia of Philosophy states that, according to surviving sources, Anaximenes flourished in the mid-6th century BCE and died about 528 BCE. That date should be handled gently. We do not know his life in the way we know a modern biography, but we can say that the surviving tradition places him in the mid-6th century BCE, after Thales and Anaximander in the Milesian line. Anaximenes is best known for holding that air is the source of all things. That is the central idea for this episode. After water gave us Thales, wind gives us Anaximenes. Water had seemed fundamental to one early thinker. Air became fundamental to another. This does not mean Anaximenes meant modern atmospheric gas. He was not doing modern chemistry. He was asking an ancient natural philosophical question. What is the underlying stuff or principle from which the changing world arises? Air had advantages as an answer. It is everywhere. It can seem neutral and indefinite. It is often invisible, but it becomes visible or sensible through motion, temperature, breath, cloud, wind, and weather. It surrounds all living things. It enters the body as breath. The IEP account emphasizes Anaximenes' theory of rarefaction and condensation. Air becoming thinner or thicker could account for other things. In the ancient testimony, when air is thinned, it becomes fire. When condensed, it becomes wind, then cloud, then water, then earth, then stones. This is not modern physics, but it is an attempt to explain change through a process. That matters. Anaximenes was not simply naming air as sacred or poetic. He was trying to give an account of how one underlying material could become many appearances. The hand can help here. The IEP account mentions the familiar example associated with Anaximenes. Breath from relaxed lips feels warm, while breath through pursed lips feels cool. The example is simple, bodily, and memorable. It links air, motion, density, temperature, and sensation. For a sleep narration, that example can be very soft. Do not ask the listener to perform it actively if they are resting. Simply imagine it. Warm breath on cold hands, cool breath blown gently across soup. The same body, the same air, different motion, different feeling. Anaximenes' air is therefore not empty space. It is material possibility. It can thin, thicken, warm, cool, move, and become. It is the world before the world takes visible shape. This is where the wind episode becomes philosophical in the proper sleepy cat way. We are not asking the viewer to believe Anaximenes as modern science. We are asking what made the idea reasonable, beautiful, and historically important. Air surrounds the listener right now. It is not seen. It is still present. It moves in and out with every breath. It touches the room. It waits in the curtains. It is easy to understand why an early philosopher might treat it as a clue. After Anaximenes, air enters a different kind of system in Aristotle. In On Generation and Corruption, Aristotle discusses the simple bodies and their qualities. Air is hot and moist. Fire is hot and dry. Water is cold and moist. Earth is cold and dry. We can present this as ancient natural philosophy, not modern science. Aristotle's elements are not the periodic table. They are a way of organizing perceived qualities: hot, cold, moist, dry, upward and downward tendencies, transformation among simple bodies. Air, in this scheme, is not merely wind. It is one of the simple bodies of the sublunary world, understood through qualities and relations. It shares heat with fire and moisture with water. This makes it a kind of middle presence, connected to change. Aristotle's text describes transformations among the elements. Fire and air share heat, so if the dry in fire is overcome by moist, air can result. Air and water share moisture, so if the hot in air is overcome by cold, water can result. This is an ancient way of explaining change through the alteration of qualities. For the listener, we can keep the image simple. Imagine 4 bowls on a low table in a quiet room. One contains a small flame. One contains water. One contains dark soil. One is empty, except it is not truly empty because it contains air. The old system would not see these as isolated objects only. It would see relations: heat, cold, moisture, dryness, rising, falling, changing. Air is especially gentle in this table because it resists being held. You can cup water, you can hold earth, you can tend fire in a lamp. Air escapes the hand. It is known by breath, movement, temperature, and touch. We can avoid mocking the old system. There is no need to reduce it to, they were wrong. A calmer thought is, this was not modern chemistry, but it was a serious attempt to make sense of experience. The 4-element scheme also lets the series feel connected. Fire was hot and dry. Water was cold and moist. Air is hot and moist. Earth, when we reach it, will be cold and dry. The series becomes a slow circle around the ancient table. Air's place in Aristotle also prepares the Stoic section. For the Stoics, air and fire become active in a new way. Breath, heat, tension, and order begin to belong together. The Stoics come later than Anaximenes and Aristotle. Stanford Encyclopedia of Philosophy lists Zeno of Citium, the founder, as 344 to 262 BCE. Cleanthes died in 232 BCE. Chrysippus died around 206 BCE. Those dates belong in chronological order if the story uses them. Stoic philosophy is broad, but the wind episode needs only a careful physical thread. In Stoic thought, pneuma, often translated as breath, is part of a material account of how bodies are held together and how living things are organized. The Stanford entry explains that the Stoics identify two elements, fire and air, as active, while water and earth are passive. The active elements, or the hot and cold principles, combine to form pneuma. Pneuma functions as a sustaining cause in bodies. This is delicate material. We should not turn Stoic pneuma into a modern spiritual or medical claim. It remains historical. The Stoics had a material theory in which breath-like pneuma pervaded and organized bodies. That is fascinating enough without modernizing it. The entry describes pneuma as having inward and outward movement, a kind of tension or tensility, giving qualities and unity to bodies. For plants, animals, and rational beings, pneuma appears in different degrees or functions. For a quiet narration, the word breath can do much of the work. Breath is physical and symbolic at once. It is air, but not merely air. It is the visible rhythm of life made invisible. You see the chest rise, but the breath itself disappears. The Stoic idea belongs beautifully in the wind episode because it treats the unseen not as nothing, but as a sustaining activity. Air and fire, breath and warmth, body and order. The old system gathers them together. Imagine a colonnaded porch in Athens, after the heat of the day has softened. The painted stoa gives the school its name. People gather. Air moves between columns. A teacher speaks of nature, body, reason, and order. The voice itself is carried by breath. That image is partly atmospheric, but it is not false to the topic. Philosophy was spoken before it was printed for us. It moved through air. Every argument depended on breath, hearing, and the invisible medium between speaker and listener. The Stoic section can close by returning to humility. Ancient pneuma is not modern oxygen, not modern neuroscience, not a health claim. It is a historical way of thinking about how matter, life, order, and breath might belong together. Now we can gather the dates in order, softly and clearly. In the mid-6th century BCE, Anaximenes of Miletus treated air as the source of all things. The surviving tradition says he died about 528 BCE. His air was not modern gas chemistry. It was an ancient principle of change, thinning and thickening into fire, wind, cloud, water, earth, and stones. In Aristotle's system, preserved for us in works such as On Generation and Corruption, air became one of four simple bodies organized by qualities. Fire was hot and dry, air was hot and moist, water was cold and moist, earth was cold and dry. In the Hellenistic period, the Stoics developed another material account of breath and body. Zeno of Citium lived from 344 to 262 BCE. Cleanthes died in 232 BCE. Chrysippus died around 206 BCE. In Stoic physics, pneuma, or breath, helped explain unity, structure, and living organization. Then we can move far forward, from ancient philosophy to modern weather classification. On February 1st, 2007, the enhanced Fujita scale became operational. It rates tornadoes from EF0 to EF5 using estimated wind speeds based on surveyed damage indicators and degrees of damage. On March 28-29, 2007, shortly after EF adoption, National Weather Service Amarillo damage surveys described tornado damage in the Texas Panhandle, including badly damaged semi-trucks and a refrigerated boxcar rolled 11 times and found almost 100 yards from its original location. On February 6, 2008, the Lawrence County, Alabama EF4 tornado produced another dated example of wind acting on heavy objects. A truck thrown more than 100 yards, and fence posts embedded in concrete ripped out and vaulted 50 to 100 feet. On January 17, 2012, National Weather Service Louisville reported 2 semi-trailers blown over on I-265 during a tornado. On May 15, 2012, the National Hurricane Center's minor modification of the Saffir-Simpson hurricane wind scale thresholds became effective, adjusting the Category 3, 4, and 5 mile-per-hour boundaries for unit conversion consistency. This recap can feel like setting stones in a path. Mid-6th century BCE, about 528 BCE, 344 to 262 BCE, 232 BCE, around 206 BCE, February 1, 2007, March 28, 29, 2007, February 6, 2008, January 17, 2012, May 15, 2012. The point is not to make the listener memorize them. The point is to keep the episode honest. Dates give the drifting mind a quiet rail to follow. By the end of the spoken section, the strongest wind has passed. No more new storm facts are needed. No more damage scales, no more dates. The listener should be allowed to return to the room, the curtain, the grass, and the breath. Wind has carried us across a wide field. It began as comfort, air moving over skin, helping heat leave the body under the right conditions. It became cold wind, drawing heat away too quickly. It became pressure on walls and roofs. It became hurricane force wind, measured by sustained speed. It became tornado damage, estimated through what the wind changed. It lifted debris. It gave momentum to small things. It moved heavy things in documented cases. It pushed fire toward new fuel and carried embers downwind. It also filled sails, cleared rooms, moved grass, cooled faces, and gave ancient philosophers one of their deepest images for life and unseen order. Anaximenes saw air as source. Aristotle placed air among the elements. The Stoics spoke of pneuma, breath-like in material, holding bodies together. We do not need to believe their systems as modern science to understand why air mattered. Air is invisible, but not absent. It is delicate, but not powerless. It is ordinary, but not simple. Now, imagine the last scene. A dark field, tall grass, a slow sky, no storm nearby, only the steady movement of night air. The grass bends and rises. A curtain stirs in an open room. Somewhere far away, clouds pass over the moon. There is nothing more to solve. The wind no longer needs to be measured. It does not need a category or a scale. It can simply move. Let the breath be easy. Let the room be quiet. Let the air around you remain ordinary and kind. If the mind wants one last image, let it be very simple. A window is open a little. Outside, the night is dark, but not empty. Somewhere beyond the glass, leaves turn their pale undersides and settle back again. The curtain answers with one small movement, then another. The facts can rest now too. The categories, dates, scales, and sources have done their work. They helped us keep the story honest. They helped us distinguish a breeze from a gust, a hurricane category from a tornado rating, a sourced example from a rumor, and an ancient philosophy from modern science. What remains is air, not dramatic air, not dangerous air, just the quiet medium that has been here the entire time, around the room, around the body, around the old questions, around the words themselves. It has carried every sentence in this episode. It carried the first invitation, the descriptions of storm scales, the careful dates, the old names, and the slow return to quiet. If this were spoken in a room, the air would be the bridge between voice and ear. Even in recorded form, the thought remains, air is the imagined path of sound. That is a fitting place to end a wind episode. The topic does not close by becoming smaller. It closes by becoming familiar again. The same wind that can be classified, surveyed, and sourced is also the little movement at the window. The same air that old philosophers wondered about is the air of the present room. Nothing needs to be forced into mystery. It is enough to notice that ordinary things can be deep when we attend to them slowly. And slow attention is exactly what this quiet hour has been for. One breath at a time, gently, patiently, and without any hurry. So let the last thought be a gentle one. The invisible world is not always far away. Sometimes it is close enough to breathe. And now, for the rest of our time together, we will leave the words behind and rest with the sound and motion of the wind. Before the words fall away completely, we can linger a little longer with the gentlest kind of wind. Not the wind that breaks branches, not the wind that throws rain sideways, not the wind that asks anyone to hurry. Only the slow movement of air at night, the kind of movement that makes a curtain lift and settle again, or turns the grass in one soft direction and then lets it rise back into place. This is the wind after the lesson has ended. It does not need a scale. It does not need a warning name. It does not need a number. It can be only motion, crossing the room quietly, touching the edge of the blanket, moving across the face so lightly that the body receives it before the mind thinks about it. In that quiet, the old questions become less demanding. What is air? What is breath? How can something invisible carry sound, cool the skin, feed a flame, move clouds, and become one of the oldest images for life? The answer does not have to arrive sharply. For sleep, it is enough that the question has been treated honestly. We have let air remain physical. We have let it remain ancient. We have let it remain ordinary. And now, in the last spoken minutes, we can let it become familiar again. Imagine a window open just a little. Outside, the sky is dark and low. Clouds move without needing to be named. There may be trees beyond the glass, or tall grass, or the faint outline of a roof against the night. The whole scene is made of small movements. A leaf turns. A loose thread trembles. A curtain leans away from the wall. The room breathes with the weather outside it. The body can answer by doing very little. There is no need to control the breath. There is no need to make it deeper than it wants to be. Air enters. Air leaves. The rhythm continues in its own quiet way. If a thought returns to the strong wind we discussed earlier, let it pass by like a cloud moving behind another cloud. The strong wind belongs to the world, but it does not have to remain in the room. Here, only the gentler edge of the subject is needed. The same element that can press against walls can also brush a sleeping face. The same atmosphere that carries storms can also hold a quiet night. The same air that old philosophers wondered about is the air resting around the bed, around the chair, around the lamp, around the small spaces between things. This is why wind makes such a good ending. It does not close like a door. It fades into presence. You can stop looking for it and still be inside it. You can stop thinking about it and still be breathing it. You can stop naming it and still hear what it touches. A soft sound in the trees, a low movement in the clouds, a small hush around the window frame. The old word breath can become simple again. Not a theory, not an argument, just the quiet exchange between the body and the room. One breath arrives, one breath leaves. Another leaves. There is patience in that. There is no hurry in the air. Even when clouds move quickly above the earth, the sleeping mind can receive them slowly. Even when the wind outside has texture and change, The listener can let it become a soft background, a moving wall of sound with no sharp edge. The facts have already done their work. The dates are set down. The scales are named. The old philosophers have had their quiet moment. Now the video can stop asking for attention. It can become a place to rest. The next sounds may be wind in trees, or the imagined wind inside dark clouds, or the low movement of night air passing through open space. Let those sounds be enough. Let them carry what remains of the episode without words. Let the room soften again. Let the eyes become heavy if they want to. Let the thoughts loosen. If the mind is still awake, let it have something very simple to hold. A dark sky, clouds moving through it. They do not need to become a forecast. They can be only shape and shadow. One soft mass crossing another. One blue-gray edge dissolving into a darker blue. The wind is visible there only because the cloud is willing to move. Below it, there may be trees. The branches do not move all at once. Some answer first, some answer later. A higher branch bends before a lower one. A leaf turns, then another. The sound is layered, but still gentle. It is not a sound that asks the body to prepare. It is a sound that lets the body stop preparing. That is the difference between a warning and a bedtime wind. The same moving air can belong to many worlds, but here, in this last little passage, it belongs only to rest. Let it move through the trees without urgency. Let it move across the dark clouds without meaning anything more than weather passing through the night. Let it move around the house not as a threat, but as a reminder that the world continues outside the room. The blanket remains warm. The body can be quiet. The mind can listen without following every change. If there is a stronger sound for a moment, it can pass. If the wind softens, it can pass too. Nothing here has to be held. The whole point is to let the air carry things away. A leftover thought, a small worry, a phrase from earlier in the day, a question that does not need answering tonight. The wind can take each one lightly, not because the wind understands, but because the mind has allowed itself to release. This is why a simple sound bed can be kind. It gives the mind a place to go that is not empty. It gives attention a texture, a soft movement, a dark surface that changes slowly. There is enough happening that the silence does not feel bare. There is little enough happening that nothing demands a response. Wind in trees can do that. Clouds can do that. Night can do that. A low, steady sound can become a room of its own. And in that room, the old meanings of air become quiet again. Air as breath, air as motion, air as the unseen space between voice and ear. Air as the presence that touches everything without needing to be held. The ancient thinkers are far away now. The storm scales are far away. The careful dates are far away. They are not forgotten. They have simply settled. They have become part of the dark background, like hills after sunset. What remains close is much smaller. The next breath, the next soft movement outside, the next moment in which nothing needs to be done. Let the body notice the mattress. Let the shoulders loosen if they want to. Let the jaw rest. Let the hands be still. The wind does not need help. It will keep moving. The clouds do not need help. They will keep crossing the sky. The video does not need attention now. It can become background. It can become a dark window. It can become the suggestion of weather far above the room while the listener remains safe, warm, and quiet below it. That is a good place for the wind episode to finish speaking. Not with a conclusion that closes everything tightly. Not with a final argument. Only with a return to what was present at the beginning. Air moving, breath arriving, breath leaving. The invisible world close and ordinary. The invisible world is close. Close enough to feel at the edge of the skin. Close enough to hear in the movement of leaves. Close enough to breathe without thinking. And now, truly, for the rest of our time together, we will leave the words behind and rest with the sound and motion of the wind.